My name is Wellington. I will present the article entitled IoT Sensor Integrated with Distributed Protocol IOTA Tangle, Bosch XDK110 Use Case. This work was developed from a user partnership. I, Wellington, I am a master student at the Federal University of Santa Catarina and was studying about IOTA with my professor advisor, Roderval. Daniel de Michel is XDK2Man founder. The XDK2Man is a project executed in partnership with the Bosch and IOTA Foundation. Daniel Traub did a very interesting application job with the IOTA at Aachen University. We joined forces to develop this work, which consists of presenting potential limitations and how IOTA distributed ledger can be used to collect data from IoT devices. We know that, in principle, a decentralized system can provide privacy, security, and immutability, without relying on a central authority or specific hardware. This is very interesting for saving or sharing data from IoT devices. The most famous distributed ledger technology is the blockchain, but the blockchain has an inherent design limitation for IoT application. The blockchain made of a sequential blocks with multiple transactions within each block. The result of this is necessary have to wait the next block to insert data in the network and pay fees for miners. And additional incentives for miners generate priority of the transactions, which can be very costly, especially for data flow from IoT devices. On the other hand, the IOTA protocol proposes a distributed ledger directly acyclic graph based named the Tangle. To enter information or data on the network, just approve two other transactions. There are no miners or blocks, just transactions that occur in parallel to each other. However, we have not found in the literature any studies that demonstrate how the connections between sensor and IOTA can occur, or that the characteristics and limitations of this type of system. We started exploratory technological research in modeling a system that allowed the integration of IOTA with the multi-sensor device called Bosch XDK110 that was especially designed for rapid prototyping of sensor-based products and applications for IoT. IOTA is a cryptocurrency we can better understand. It's a distributed protocol designed for IoT. Among its main characteristics for this purpose we can mention zero fee, high scalability, and low latency. This is only possible because the IOTA DLT is DAG-based, with the characteristics very young. As I mentioned, the XDK110 was designed to facilitate the prototyping of sensor and applications. Therefore, it's all measuring 8 types of data: accelerometer, gyroscope, magnetometer, humidity sensor, pressure sensor, temperature sensor, acoustic sensor, digital light sensor. And they are modular, that is, they can be purchased separately. In addition, data can be sent through several types of connections: Wi-Fi using HTTP or MQTT protocol, USB, LoRa, and Bluetooth Low Energy. The model of sensor integration with IOTA takes into account the characteristics of this ledger. For example, the need to realize the proof of work. For a transaction to be attached to the network, it's necessary to realize the proof of work, which may take a few seconds. That is, it's not possible to publish and receive data from the sensor in real time directly from the Tangle. Another important issue to consider is that the protocol allows outsourcing the proof of work to another device or funnel. In addition, we take into account that's important that sensor and SOCs sending data to external resource due to low computational power that they generally have. In your model, the sensor data is sending to a kind of server that is responsible for three things: receiving the data, group data set, construct your IOTA bundle and broadcast then to IOTA full node, and show the data to the client through a web application. For sending the data for IOTA, it's possible to use a IOTA library. The received data by the server will depend on the sensor device used and the type of the communication will be used. And the web application can also develop it in several ways. This model resolves several issues. First, it's it, it's possible to view data. It's not necessary to wait for to publication in the Tangle to view it. Second, after a few seconds, it's possible to check integrity mutability in the distributed ledger. Third, we group data from the sensor before sending to the Tangle, which imply less computational expense to perform the proof of work. 4. It's possible to use the same server for different sensors, saving resources. 5. No additional fees is spent to insert data into the distributed network due to characteristics of the IOTA Tangle. 6. Any actor interested in the data will be able to check even outside the web application in any location. As already mentioned, depending on the sensor device, communication with the server can happen in different ways. In this case of the XDK110, it's possible to communicate using USB, HTTP, MQTT, LoRa, and BLE. We choose to use the HTTP method as it's popular and does not require server near the device. So the device is connected to the internet through a Wi-Fi network. However, in this article, we present libraries adjust to perform the integration for any type of communication. We choose the IOTA JavaScript library to build the bundle and send data to the distributed network. We choose it because it's the most completely library for this purpose. The web application was developed with Node, React, and MariaDB. The developed web application has this dashboard for the client and contain all the sensor data. And as I already say, the data present in this graph are obtained directly from the sensor via HTTP. At the same time that they are grouped and send data to the Tangle and cannot be changed anymore. The integrity of this data can be observed by clicking on the chain button. Written after the proof of work can be audited by any interested actor. We use the IOTA main library to record data streams in the Tangle. This allows access to the channel of the sensor, verifying data on the network. The data can be visualized in any full node of the ledger. With the channel ID, it's possible to guarantee the integrity of the message and can be seen in this screen. A proof of concept was developed at Ashton University using architecture modeled here with XDK110 and IOTA Man. A present industrial cutting machine find bank and produce parts for the automotive area. However, several signings during the production can be analyzed, especially when we consider the increasing of demand for data transparency in supply chain combined with the clear clarification of responsibilities for intervention and change, unauthorized interventions, because they can sometimes have extreme effects the condition and quality of the product. In the case the fine bank machine, the product is not identical to the other, which means the small variation will have different results, and mapping of this data facilitates the auditability in case of the unexpected results. Not just the manufacturer, but for those who will use the product. For this case, a kind of digital twin of the machine data was created directly in the Tangle. In this case, a local computer recovered the data and created the IOTA bundle. In your proposal to use the IOTA network was a distributed protocol for sensor data, we are able to insert granular data from the sensor without any loss or fees, and low latency when compared to the other distributed ledger technologies, maintains the confidence and the immutability of the data, and has no need of central authority. The proposed model also allows all the data which can be visualized from the sensor and quickly check to the data in the IOTA public ledger. In addition, anyone interested in the data can verify the integrity of the data directly in the Tangle, facilitating the trust between different actors interested in the data. Finally, it can be said the IOTA protocol is promising for IoT, and the proposed model can be used to store security and mutable data streams.